Okay, as always, when we learn a new technique, the next thing we do is we start dealing with quote-unquote real-world kind of problems. They're not all realistic, but anytime you're in the real world, you're not going to get someone handing you an equation when you need to solve a problem. You're always going to have to deal with words, right? We think in words, we communicate in words, we solve problems in words. So we're going to go ahead and try out these word problems. Well, let's see. Together, Lulu and Jessica ate 7/10 of a pizza. Lulu ate 4/10 of the pizza. What fraction of the pizza did Jessica eat? Well, they had 7/10 total minus, well, Lulu ate 4/10. So hopefully you can see why we're subtracting and not adding. We would add, like if we knew that Jessica ate 7 and Lulu ate 4, then we would add them together to find out the total, but that's not what they gave us. They gave us the total minus the amount that Lulu eats. Jessica eats 7 minus 4 is 3/10 of the pizza. Hope that makes sense. Oop, that's not right. It would help if I could type. The table shows the heights of 3 different plants. What is the height of the tomato plant and the bean plant combined? When we say the word combined, this is good. We're talking code words. This is the way, whoops, that's not what I meant to do. This is the way that math word problems work. It's a translation. When I see the word combined, that usually tells me to add. Yeah? Combined means I take 2 things and I add them up. So, combined, I would take the height of the tomato plant, which is 5/8. I would take the bean plant, which is 2/8. And because I'm looking for the combined height, I add them together. 5 plus 2 is 7/8. Bjorn is making his favorite dessert. The recipe calls for 5/8 of a stick of butter, but he wants to double the recipe. Now, doubling is multiplication, but as we have talked about before, multiplication is addition, right? It's just repeated addition. Now, because we have not gotten to the multiplication of fractions yet, we are not going to look at this as 5/8 times 2, okay? We could, but we are not going to do that today. We're going to do that in a later video. For now, we're going to look at this as 5/8 plus another 5/8. Okay? And hopefully the answer that we get will help you understand multiplication a little bit better when we get there. So I have 5/8 of a stick of butter. I've got another 5/8 of a stick of butter. Each of my fingers is 1/8 of a stick of butter. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 eighths sticks of butter. That's my answer. And this might seem weird to you because when you multiply by 2, you might think it would be 5/16 or 10/16. But if you think about that for a moment, 10/16 would be the same as 5/8, right? You're not actually doubling it. If you double both the numerator and the denominator, you're just cutting everything in half. You're not actually changing the value. We did that in the last video. Kira worked 87 out of 100 of the problems in her math test in the first hour. After her second hour, she had worked 97 out of 100 of the problems. What fraction of the problems did she work in the second hour? So again, this is just 97 minus 87. This is 97 minus 87. She did 97 questions after 2 hours. She did 87 questions after 1 hour. You subtract them. She only did 10 questions, maybe they were very difficult, in the second hour. But each question is 1/100th of the test. So she has done 10/100ths of the questions in that second hour. which does indeed reduce down to 1/10, but we're not quite there yet either. The table shows the amount of apples 3 friends collected. How many buckets did Fred and Taylor pick combined? Again, that word combined means add them up. Fred picked 5 buckets. Taylor picked 6 buckets, but it's not actually 6 buckets, right? It's 5/6 of a bucket. I just hate saying that word sixths. So 5 plus 4, there's a total of 9/6 of a bucket. A child's ladder is made of 3 sections. Each section is 3/4 of a meter long. So when you put all 3 of them, that would be 3/4 plus another 3/4 plus another 3/4. Well, 3 plus 3 plus 3 is 9/4. Pedro is supposed to practice piano for 4/6 of an hour every day. Today, he has practiced for 2/6 of an hour. Now, this is what I'm talking about when I say that these word problems are not always realistic, right? We don't talk about time in terms of fractions. This is just trying to provide some context on dealing with fractions. I do wish they would choose something that was a little bit more realistic, though, than using fractions for hours, which we don't do. Anyway, the fact of the matter is, if he's supposed to do it for 4/6, he's already done it for 2/6. The only question is, are we adding or subtracting these two values? Well, he's already done 2. It's not that he has to do 4 and then do 2 more. It's that he has to do 4, but he's already done 2 of them. We are subtracting, and he has 2/6 of an hour left to go. There we go. Adding and subtracting word problems with fractions, same denominator. We got this. Let's move on.